Welcome back to ICE. In part 2, we're going to look at XML schema. We're going to look at schema declarations, and within the schema declaration, there are a number of element declarations, and then we're going to look at attribute declarations to go with elements, and then for the elements and attributes, we need to declare their type, which can be simple or complex. Simple if they mainly contain strings. Complex types are if the elements themselves contain other elements. Now to declare a schema, we need to create the name for the namespace that is used. So the language that is used to define XML schemas is itself an XML language. In other words, it's a set of tags or a set of elements that you use to declare an XML schema. And the namespace corresponding to the set of tags that you use or the XML language that is used to define XML schemas is given as follows. So from this standard namespace, http://w3.org XML schema, and this just say that XSD is an abbreviation for this whole namespace. And then from then on, all the relevant tags will be prefixed by XSD. Then you close it, right? So every schema will start with that and end with that, every XML schema. So let's look at some element declarations. So to declare an element, you use this tag called xsd::element, and then the name equals to customer, and the type is going to be a string, right? So you're declaring a customer name. So you're declaring a customer element, right? And you can also have attributes and data types. So you can declare customer to be of a complex type in the sense that customer element contains other elements, so forth. So this is an instance of this particular XML schema, right? So you can see that customer is complex because it contains other elements such as cust name, for instance. And customer also has an attribute called CUSTID of type string, right? And that's the declaration for this attribute here. So this is an attribute of the customer element, and you declare that there, right? So that says that the customer element has an attribute called custID. It also contains at least one other element called cust name, right, which is shown here. And this is of type string, this of type string, this of type string, this of type string. So not PC data or C data or anything like that, as in DTDs, but in the XML schema, we just say XSD::string, right? And you can see the prefix XSD here in the sense that all these types like string and all these tags like element, complex type, and so on comes from the namespace XSD, and XSD as shown here is an abbreviation for the standard namespace for XML schema. Okay, so here's an example on the left hand side, an option for declaring the element purchase order to be of type purchase order types, and then you can say name the type, right? In this case, the name of the type for purchase order elements is purchase order type. And then what does purchase order type contain? Well, it contains a sequence of elements and as well as an attribute, right? So you can give a name for this type, and giving a name for the type can be handy, right? Because you can reuse it. But if you don't want to give it a name, you can just include the entire complex type definition into the element itself, right? So this says the same thing as the other. It also says purchase order is of this complex type, so a purchase order element will contain all these elements and then an attribute. But you notice that the yellow bit is the complex type definition and there's no name given to it. But in this, a name is given to it, which is purchase order type. So you can have unnamed types, which you just embed in the element declaration itself. But otherwise, these two are the same. In general, this is preferred because you're giving names for complex types, which you can then reuse elsewhere, right? So you can declare another element called purchase order something else, and you can declare it to be of type purchase order type as well. So for instance, you declare a new element called buying order, and you can say it's of this type. New order is also of this type, right? So giving the type definition a name helps. Notice a bit of terminology. When we declare an element, right, we declare the name of the element and then the type that goes with it, the type of the element. And when we declare an element, it's called an element declaration. So we say element declaration, we don't say element definition, right? It's just a terminology. And within an element declaration, you can have the type of the element, which means that you define a type here. So when you talk about types, we say type definition, we don't say type declaration. So within an element declaration, such as purchase order, we have a type definition, which is here. And then within a type definition, notice that we also declare elements like ship to, build to, and so on. And this is a way to refer to an element which is defined elsewhere, defined outside. So within a type definition, you have element declarations, and within an element declaration, you have type definitions. In attributes, you can declare the data type and restrictions, just like in DTDs, you have hash implied or hash required. In this case, you can use the attribute use equals to required, which means that this attribute access n is required, right? Elements may have a type defined for them. The types are simple or complex. And if you look at simple types, it can be, for instance, a form of restriction, right? So you want to declare a simple type called part number, and the base of it is a string. In other words, part number is a type of string whose length is 12. Fixed is true, that means it's exactly 12. So you can define a type for part number, which is a set of all strings whose length is 12, right? So it's a subset of XSD colon string, and that's how you declare a simple type like this. And it's still a simple type rather than a complex type because there are no elements inside this type. So a complex type definition would be complex in the sense that it contains other elements, right? And normally it's a sequence of elements and enumeration types may be defined. So here's an example. So you have element and name called person. So in this element declaration, we have a complex type which comprises a sequence, and then it has a name, address, city, and then the number of occurrences, right? So it's saying that you have exactly one occurrence of name, and that's the default, so you don't have to put it. If max occurs is 1, min occurs is 1, that's the default. You don't need it. You don't need to actually say that. This you need to say, right? If you want to have 0 or more address elements, the mean occurrences is 0, maximum occurrences is unbounded. That's equivalent to the star, if you like, in DTDs. Similarly with this. And you want to say gender is either M or F. So you declare the element name gender. What can it contain? Well, it's a simple type. So it can contain a string, and not just any string, but this is like an enumerated type in Java, right? So it's an XSD string. So within the element gender, it can only contain M or F. So notice you can specifically define what type of strings you can have within that element, which is a lot more expressive than DTDs. In DTDs, you can only say C data or PC data, a string or not a string. But in this case, you can say what kind of strings are allowed. Okay, you also have a type definition hierarchy, right? Just like in Java, if you can declare types, you have a type definition hierarchy, complex types, and then built-in types as well, or derived types, and get a complex type hierarchy here. And when you declare a data type, or you have a type definition, you want to declare value spaces, lexical spaces, and facets. So value spaces are actually the set of values that you can have. Lexical spaces is how those values are represented, how they are actually written. And facets involves fundamental or constraining facets. So for instance, if you are looking at the set of all strings of length 12, the fundamental facet would be the strings, right? Because it's the larger containing set. Constraints would be is of length 12. The set of values the type can accept, thus the value space, and lexical representations is a set of representations for values, and that's a lexical space. So you may have the same value, but you can represent it in different ways. So for Boolean value, you can use 1 to represent true, or maybe true to represent true, or yes to represent true. Or if you have a number like 100, you could be represented in 2 different ways. So the value space, in terms of the value space, is only one value, but you can have different lexical representations, right? So there's only one element. For that one element in the value space, you have 2 or more possible elements in the lexical space. Right? Cardinality implies the size of a set, how many different values you can have. For instance, M or F means that you can only have 2 possible values. Fundamental facet is like the value space, is like the big subset in which the values must be found in, right? And for instance, decimal or integer. And then you have a set of constraints that you place on the value space in order to declare some subset of the fundamental facet, if you like. Right. So here's an example to say that this is simple type about schema recommendations. This is the name of the type, and it is referring to URLs of a certain type, right? So there are only 2 possible values in this enumeration type, which is that, and which is a subset of URI. So it is just saying that anything of type schema recommendations would be a URL, not just any URL, but either one of these 2. Of course, you can list 10 or depending on the application. Here you can declare a set of integers in a range -2 and 5. So this declares a data type, right? So if something is of type integer, it's going to be an integer whose range lies between -2 and 5. Inclusive, so includes -2, exclusive, so excludes 5. So it's actually -2, -1, 0, 1, 2, 3, and 4. So it's a subset of the set of all integers. So you can also declare patterns and so on. So data types will have at most one form, one from each column. So a data type is atomic list or union is either primitive, that means it's built in, or is derived from some primitive data types, for example, by adding constraints. And atomic types cannot be broken down like string or decimal, for instance. And notice that all these are predefined in the XSD standard namespace. Enumeration restriction, right? So you can declare element of type items to be a list of strings, right, using this special declaration here. So you want to say that elements items should be simple type. So what's in the items element would be just a list of strings like this, space separated by default. Here you're saying that my integer list is a list of integers, each of which is less than or equals to 100. So for instance, if you want to have an element called prices and the value that's in that element is some integer that is less than or equals to 100, then that's how you declare it. Union types, right, just like unions in C, in the programming language C. So it's saying that my integer union is either an integer or an NM token, which is undefined, right? So it's saying that the value of this is either integer or undefined. So undefined is actually a keyword found in XSD:NM token, a special token, if you like. You can have primitive base types built into, and there are some that are built into schemas, like those 4 is standardized, and you can add restrictions to that to derive types. And so for instance, set of all strings of a certain length, not all decimal numbers, but decimal numbers within a certain range, and so on. Right? So you can derive from these primitive base types your own data types by adding restrictions. So here are some examples of derived types, and you can specify a pattern. Right? So a set of patterns that follow this, a set of strings or a set of tokens that conform to this pattern can be declared like this. And here you just derive uh, decimals from the set of all integers, right, with fraction digits value equals 0. So all fractions with value digits equals to 0 is an integer. So there may be more than one description. Primitive types are atomic, union types are derived, Boolean is union type that is primitive. So you can combine them. So DTDs don't provide a way to define data types as we have seen, right? And that's why we have moved on. The world has moved on from DTDs to XML schemas. But still, we learn about DTDs just in case you encounter them somewhere. So why use XML schemas? Well, it's a pretty elaborate way to define an XML document, to define the set of elements or the set of tags and what those elements can contain. Right? But the idea is that it's quite expressive in terms of defining the contents of elements or the contents of attributes. So the idea of types is that, so XML schemas are quite expressive in terms of defining the type of elements and what elements can contain, what values elements can they contain other elements or not, and then what values would be legal in the values of attributes, if you like. So that's the idea of a data type, right? So when you say that within the element it only contains certain elements, or you're defining a type of things, right? Those things which comprises those elements, for instance. Or if you say that the value of the attribute must be of a certain value, you're defining a data type, basically. And that is the person example. Right? So if you compare the two, right, we've seen this before on the left hand side, the TDT for person information, and the right hand side is pretty similar. You can see that it's pretty similar, but it's certainly more expressive. So whatever that you can define DTDs, you can define using XML schemas, and here you can get more expressive, right? Gender here is only PC data, that's all you can do, but here you can say M or F. It's here that you can really set the min and max occurs. So for instance, for address, if you want to say that you can have up to 0, 1, 2, or 3 addresses, no more than 3, then min occurs is 0, max occurs will be 3, for instance. And here's an example of an XML document that conforms to the schema in the previous slide. So you just declare that it is a standard way to associate, if you like, this XML document with the XSD schema. Right? Just saying that this XSD schema is a schema that is based on this standard namespace has been defined using tags from the standard namespace. And suddenly a schema location, instead of a name of an XSD file, it could be a full URL pointing to the XSD file. Right? And you notice that you can declare the XML version and the encoding. This is a Unicode encoding, right? Which means that instead of these tag names, instead of English, it can be any language that you want. And that's what the schema looks like.